Damn! They are so precise with this stuff.
Well, that was easier than expected.
So this is what Oni meant when they said the best of the best.
It's beautiful! Ah, thanks, Mac. Huh? Not you! Oh, I'm not beautiful?
Hey, what's this button do? Beep. What am I?
One second. Hey, you looking to get your Halo Infinite Spartan into VRChat? Well, look no further. To begin with, you'll need to have Halo Infinite installed, so we have all the source files to pull from. On the program side, we will need to download the 3D modeling software Blender and Eker, which is our extension for Blender that we can use to import the Spartan from Halo Infinite. Once you have Blender and Eker installed, open the Spartan template.blend file in Blender. For the first time setup, we'll need to adjust some settings. Go to File, External Data, Automatically Pack Resources off. Go to Edit, Preferences, System, Cycles Render Devices, select the option that fits your GPU the best, in my case, OptiX for NVIDIA RTX GPUs. Go to Themes, 3D Viewport, Face Orientation Front, set the alpha to 0. Go here, Viewport Overlays, select Face Orientation On. This will make it so that we can determine the back and front faces of a mesh much easier. Optionally, if you want to use the same Blender keybinds that I'll use in this tutorial, go to Edit, Preferences, Key Map, and import the file that you can find in the description for the binds. Before pulling your Spartan to Blender, you want to ensure that the Spartan in Halo Infinite currently looks the way that you want it to look in Blender. So ensure you have the correct armor and colors applied. Also, take note of the body type setting of your Spartan and any potential prostheses you may have applied, as we will need these shortly. You can find these in the body and AI setting in Halo Infinite. Once you've got all that figured out, we can now import our Spartan to Blender. Press N to open the side menu, go to Eker, go to Import Vanity, set your body type, potential prosthesis, and your gamertag here. Then just click Import Spartan from gamertag. This will freeze your Blender for about 2 to 5 minutes, so just wait it out. Once we've got the Spartan imported, go ahead and go to the hierarchy on the right, right-click Spartan Control Rig V2 and delete hierarchy. This will delete the existing IK rig attached to the Spartan, as we will use our own rig later. Now confirm that the Spartan you imported looks correct by going to the top right Viewport Shading tab and inspecting the armor. You may run into some attachments which have imported at a wrong rotation. For these, you'll have to manually adjust the rotation to match what it looks like in-game. If you imported your Spartan with a body type other than 0 or with some prosthesis, you'll find some hidden meshes in the hierarchy on the right. These are for the original limbs and for the other body types. All these hidden meshes you can safely delete since they won't be used here. Now we will want to combine the separate meshes that make up our Spartan into 3 distinct groups: base, attach, and helmet. For the helmet group, select the helmet and any helmet attachments. Press Ctrl J to combine the 2 selected meshes together. For the attach group, select all the hands, shoulder pads, knee pads, chest attachment, potential right arm attachment, and the thigh/waist attachment. Control J to combine. We can hide these temporarily with H. Also hide the helmet. And now what we have left is the base group. So in the hierarchy, everything that's unhidden is a part of the base. So select all of those and Control J. Now let's rename these three mesh groups. Firstly, unhide them. Copy the name of your Spartan. Select the base mesh. Rename it to the name of your Spartan underscore base. Okay, you can copy the Spartan name underscore. Helmet, Spartan underscore helmet. For the attach, underscore attach. Now remove the old armature modifiers on all meshes. So select one mesh, go down here to the modifiers tab, armature, click the X here. Repeat this for all meshes. On all Halo Infinite Spartans, there's a hidden mesh in between the torso and the legs. This is only seen if you set your FOV to 78 or lower and then look down. It is there to prevent you from seeing inside the legs, but in our case, for VRChat, you'll never be seeing that mesh anyways, because you cannot look inside your body. So we can just delete that. In order to delete it, select the base mesh, go into edit mode, deselect everything that's selected, fly inside the body, hover over one of the vertices and press L. I need to do it twice here to select the whole mesh. Ensure that you have all the areas selected. Sometimes there are some faces that are not selected. Seems correct here. And then just press delete vertices. There we go. You can go back to object mode now. If the total amount of trees of the model is over 70,000, which can be seen on the bottom right here, and in VRChat you aim for any performance rank other than very poor, you need to reduce the amount of trees to be under 70,000. To achieve this, we will need to reduce the fidelity of the mesh with some decimate modifiers. Firstly, select all the meshes, go into edit mode, press Alt-H to unhide any meshes, press A to select all the vertices, Shift L while hovering over the visor to deselect the visor, then M to merge by distance, and then down here on the left, ensure that the merge distance is 0.0001. So right now we're merging very close vertices together. This is crucial for the next step. Now return back to object mode. Now select the base mesh, go into the modifiers tab, and add the decimate modifier. Adjust the ratio to be under 1 while keeping track of the trees counts down here. It should go under 70,000. You may need to add a decimate modifier to the attach mesh as well if the base mesh starts looking too deformed and you're still not going under the 70,000 threshold. But in my case, I don't need it for the attach mesh. I only need it for the base mesh. So I keep track when it goes under 70,000, right around there. Still, mesh looks good. If I go really far down, it starts looking very deformed. We don't want that. So just go right under 70,000 here. And then apply the decimate modifier with Ctrl A. In the case of this blue Spartan, the trees count was already under 70,000 to begin with, so no changes were needed there. Next up, add a new UV map to each mesh. So go down here to Data tab, UV Maps, plus, and add a new UV map called Bake to each mesh. Ensure the Bake UV map is selected on all three meshes and go to the UV Editing tab. In the UV Editing tab, we will rename all of our materials and create an optimized UV atlas for all our meshes so we can later bake the textures of the Spartan into just 3 materials. First of all, let's fix this UV image map here on the left by going to this tab here, typing in usually 0. It's going to be -1 or 0, just select one of those and we will get a nice transparent background here. Next up, deselect any selection you have by just clicking somewhere. Ensure this button here, UV Sync Selection, is off, and then we can start renaming our materials. To figure out which material is which and what they should be named, select the material and click Select. In this case, it's the bottle, and then just rename it. So that would be the thigh attachment. Next up, chest attachment, and so on. Once you have renamed all the materials of this mesh, you can go to Object Mode, select another mesh, go back to Edit Mode, and rename the materials present in this mesh. Repeat for the last mesh. And now we're ready to create the UV atlas for each mesh. Begin by going to Object Mode, selecting the base mesh, back to Edit Mode, and ensure the pivot point here is set to 2D cursor. Now we will create a UV atlas where we'll assign an area to each material so that all the materials can fit in the same single square. If you take a look at these individual materials right now, you'll see they all take up a large amount of the same square, but we will need to reduce the size of these to just take portions of this single image so that we can have them all in the same image. At this point, you'll need to inspect if there are any asymmetries in the textures of the armor. So go into Object Mode and see if there are asymmetries, such as the right leg being blue and the left leg being black. If there are asymmetries, these will need separate areas assigned in the UV atlas. But if there are no asymmetries, we can, for example, give the left thigh and the right thigh the same location in the UV atlas by overlapping those because they use the exact same texture. This way we can save some space in the UV atlas. In the case of this model, there are a lot of asymmetries in the textures, so at least for those parts we cannot overlap them to save space. But let's begin the atlasing process by going to Edit Mode. Here's a helpful UV atlas reference of the base mesh by the creator One Weird Guy that we can use to scale and position the different materials to fit optimally within the same square. Let's begin with the torso part. So select the torso material and select the waist. Go over to the left side, press A to select all the vertices here, press S and type in 0.5. This will allocate 1/4 of the square just for the torso. The torso is quite a big part of the armor, so we'll want to allocate a lot of space for it. Next up, let's do the up arm. So select both, A 0.5, and now S, Y 0.5. You can move this with the move axis holding Control, and then move it like this. We will move it in place right here. Now you'll see I overlap them both. This is what you would normally do if you don't have any asymmetries in the texture and they're actually completely identical. So by overlapping them, you're giving this allocated space for the both of these textures, but since they're using the same texture, it doesn't matter. In our case though, these have separate textures, so there's some black on the arm here, but some blue here. So we will have to assign separate spaces for them. So in this case, I'll select both the up arms, go to here, press A, S, X 0.5, and now deselect, select only one of them, and move it to the right like this. So now if I select both of them, now they have two separately assigned spaces in the UV atlas. In the case of this Spartan, I'll have to assign separate areas for basically all of these limbs since they are all asymmetrical. So following the UV atlas reference, I'll just complete the rest of the UV atlas. In the case of some meshes, there are these UV islands outside the allocated space of our square. We can actually just make these overlap with the existing UV island that corresponds to the shape of this UV island that is outside, because these are also just mirrored parts. I'll show it here. So if you select the UV sync selection and you only select this part, you'll notice it's like half of the neck, but it's also mirrored on the other side. It's a completely mirrored texture, so we can just make it overlap and it'll look right in it once we bake the textures. And now if I select all the materials at the same time and check out the UV atlas, you'll notice everything has a nicely allocated space for them. In the case of this other Spartan, there are no asymmetries in the textures. So what I've been able to do is assign the same area for both sides. So here they're both taking up the same area. And if we select everything, it looks like this. Next, let's create the UV atlas for the attachments mesh. Going into object mode, selecting the attach mesh. And this one is a bit more complex because depending on the amount of attachments, you'll need to assign spaces in the UV atlas corresponding to the size of the attachment that it takes up in the armor. So in this case, since the chest attachment is front and center, we will want to assign some more detail to that. So that means a larger space in the UV atlas. Also, you will always want to have a good amount of detail on the hands. So big space for that. Next up would be shoulders. And then lastly, the small bottle there, the knee pads, and the forearm attachment. So in the case of this Spartan, there were a lot of attachments and they were even differently colored, such as here, knee pads, different colors, hands, different colors. We also had different shoulder pads. So this is like the worst case scenario, but I made it work here. So we have hand left, right, big space for the chest attachment, then the left shoulder, left knee pad, right knee pad, the bottle, and the forearm attachment. Now we will do the remaining UV atlas for the helmet. So object mode, helmet, edit mode. And usually the helmet and visor do fit in the same square. Again here, fixing the parts of the helmet, like so. And in this case, since there is also an attachment to the helmet, we will scale this down by 0.75, x, y, 0.75, and then use the remaining space for the helmet attachment. So this one would be scaled to x, y, 0.25 and move to the top. Now when we select all of them, they all fit nicely into the same square. Now we're ready to start preparing the shaders of each mesh for the baking of the textures. Go into the shading tab, select the base mesh, go in the materials tab here and select the top material. From here, move the view so you can see this green shader tab, open it, and you'll see there's a lot of nodes here just scrambled, but we'll just need to find a couple key nodes. So search for nodes with Control F, search for group output right here, and move that to the right to the right of this principled BSDF. Then search for separate color right here, this one with one red connection coming out of it. Move that right here. Then search for power. It's this only one right here. We can just keep it here, but we need to disconnect exponent, just like this, pulling it here, and then set this to 0. So this removes the ambient occlusion of the Spartan. Now using Shift right click, we will make cuts to some specific connections in this principles BSDF node. So cut base color, metallic, and roughness. Then we will create a new node with Shift A, search combine color. We will connect metallic to blue, roughness to green, and the red from here into red. Now we're done with modifying the shader, so we can go back by pressing here. And at this point you'll want to inspect your Spartan to see if the scratch amount on the armor is good enough for you. The way the scratch is shown in Blender and the way Eker translates it from Infinite, it doesn't apply a kind of gradient to the scratch. Instead, the scratch is very plain white. So if the scratch looks too white on the armor, you'll want to adjust that. So in this case, let's see, up arm left, we would be adjusting the scratch of this part of the mesh. And the way you adjust the scratch is go down to zone 1 here and the scratch amount. Usually if the scratch looks too white, you want to change it to 0.2. But in the case here, the scratch, I'm fine with how it looks like here. So I won't be adjusting the scratch. If you do need to adjust the scratch, you need to do it for every single material. Next up, we will create an image texture node. So first of all, let's put the viewport shading to solid. We don't need to see the colors there on the Spartan itself. Then using Shift A, add a new node, image texture, and taking note which mesh you have selected, in this case base. Copy the name, go to image texture, select new, paste in the name and put an underscore at the end. Change the width and height here to be 4K, so we can use ×4, so it's going to be 4K. Ensure alpha is checked, and just click new image. Ensure here the source is set to generated. Now select this node, copy it, and paste it onto every material in this base mesh. So you can just select the material and Ctrl V to paste into every material here. When duplicating the image texture node to the other materials, you may notice that some materials, such as the one for these pineapples, have a different shader than the Halo Infinite shader, which can be found on the other ones. In this case, you'll just need to do the same modifications inside the shader as we did for the Halo Infinite shader. So finding the group output node, the separate color node, and connecting them together. After you've duplicated the image texture node onto every material of the mesh, ensure that the image texture is the selected node in each material. So go through and check that it has this white outline. Looks good, so now we can move on to setting up the render settings. Go to the render tab. Ensure render engine is set to cycles, device on GPU compute, sampling render sample set to 1, we don't need more than 1, and denoise set to off. Next, we will bake the textures onto image files. In this process, we will create 3 to 4 images with different texture data for the output material. At this point, you need to determine if any of the current materials in the selected mesh have transparent portions in the texture, as the color baking method will differ based on that. First, I'll show baking of the color texture without transparent parts, which is the case for most textures. Open the Halo Infinite shader, zoom into Principled BSDF, take the base color connection here and just connect it to BSDF here. That's all you need to do. Exit out here. Ensure the image texture here is selected. The color space is set to sRGB. In your render settings, the bake type is set to emission, and you have the mesh selected. Then just press bake. you will get the color image here on the left. Go into this hamburger menu, image, save as, attach C to the end here for color, and in this case, check color to RGB, not RGBA, since we don't have transparent parts, and press save as image. If there are transparent parts in the color texture of any of the materials in the selected mesh, such as this shoulder decal here, you'll need to bake the color texture in a slightly different way. Open the shader, duplicate principled BSDF here, move it under, take the base color from the original and connect it here, make a cut with shift right click to alpha, connect it to alpha here, and connect the output of this one into here, BSDF. Now you'll have to do this to all the materials, but since most of the materials share the same shader, you don't need to do it for everyone manually, except for the one that may have a different shader, such as this one, which is for the shoulder decal here. So since it's using a different shader, we must do the same trick here. Duplicate here, make a cut to alpha, and in this case it has a transparent BSDF and a mix shader here, so we will just replace BSDF with this shader here. Now we can exit out of the shader, ensure the image texture is the selected node on all of the materials, go to the render tab. Instead of using bake type emission, we will change it to diffuse, deselect direct and indirect in the influence, and then just bake. This will give the image texture a transparent background, so our transparent decal here will work fine. Now just save as normal. And in the save screen, ensure RGBA is selected. Give it a name and save as image. Next up, we will bake the ORM texture, which stands for Occlusion Roughness Metallic. Go into the shader, take the color from Combine Color into BSDF, exit the shader, select the image texture, set color space to non-color, ensure your bake type is set to emission, and just bake. Save that as an image. Append ORM, ensure color is RGB, and save. Next up is the emissive texture. Go into the shader, connect BSDF into BSDF, exit, select the image texture, color space into sRGB, ensure bake type is on emission, and bake. Now the output image may look completely black, but you'll notice there's a very small emissive texture here on the armor, so it's not completely black. Even though if it would be completely black, still do save the image, append E, colors as RGB, and save as image. Later we can delete this image file if you find out that it's completely black and there's no reason in keeping it. Now for the normal map texture, in the shader we already have BSDF connected, that's what we need. Select the image texture, color space to non-color, change the bake type from emission to normal, and we'll add a modifier to the mesh called edge split. Set the edge angle to 0. This will make all the angles very sharp and accurate for the normal map. Back to the render tab and bake. Save the normal map as another image, this time appending N. And lastly, remove the edge split modifier from the mesh. We have now baked all the textures that will make up the material for the selected mesh, in this case the base mesh. Next up, just repeat the same texture baking procedure for the remaining meshes. Here when creating the image texture for the attach and helmet meshes, like so, ensure the width and height are 2K instead of 4K. To change these, just select both and do times 0.5. There we go, new image. With the texture baking done, now we can attach the new rig to the Spartan and start fixing the weight paints. Go into the layout, unhide the Spartan rig. You'll notice it's rotated 90 degrees to the right. We won't be rotating the rig, but we'll be rotating the mesh itself of the Spartan. First off, press N, go to View, ensure that the 3D cursor location is at 0, 0, 0. Select all the 3 meshes, go to Object, set Origin, Origin to 3D cursor. This will make it so all of the origins of these meshes are at the same spot at 0, 0, 0. Select all the meshes, change the pivot to individual origins, select the rotation and hold Control, then rotate the Spartan 90 degrees to the right. You can see at the top of the screen the rotation, make it -90 and let go. Now while holding these 3 meshes, select the rig while holding Shift, right click, Parent, Armature Deform. We've now connected the rig to these meshes. This doesn't mean though that the meshes will move when the rig is moved. As you can see here, if I go into pose mode and try to pose something, only the rig moves. For the meshes to move with the rig, we will have to ensure that the weight paints of the meshes are set up correctly. To go in the weight paint mode, select the rig and while holding Shift, select the base mesh, top left, weight paint. Hide the other meshes so it's much more clear to see what's happening. Go down to the Data tab, up here to Vertex Groups, and in the drop down, sort by name. Scroll down in the Vertex Groups, select B Torso, and while holding left Shift, click Open the Spartan rig here. This shows up the entire armature of the rig, and we can get familiar with the bone names. The reason why this is important is that you can see we already have vertex groups with the Spartan that have the correct weight paints assigned, but these are named from different bones that were earlier on the rig. And now we have a different rig, so the way to fix this is we just need to rename these vertex groups to match these new bone names. Once the vertex group names have been adjusted to the new bone names, then we can move the rig and the mesh will actually move with the rig. Now to begin the process, go down to the bottom of the vertex groups list and start renaming these vertex groups to match the bone name of the bone that is most closely to this mesh area. For this example here, we would rename the B_spine3 vertex group, which is responsible for all of these weights around this area. We rename that to chest. So now when we would move the chest bone, the mesh in this area would move. Like so. You'll see the other parts don't move yet because they are not assigned to any bones that move along with the chest bone. Caution here on the B_torso vertex group. It looks like there's no weight paints associated with it, but they're actually hidden inside the torso here, around the shoulder area. On this Spartan, they're not visible from the outside, and that is because they're only visible if you have prostheses that extend all the way to the shoulders. Then they would be visible. In any case, you can still assign them to the chest bone here. When I assigned the chest name to this vertex group, it appended .001 at the end. That is because it's a duplicate vertex group name, and we will actually use this .001 later to combine both of these vertex groups with the same name together, so don't worry about it. Now just continuing to go up the list. So B_spine2 twist looks like it's gonna be good for this bone, which is the spine bone. So select spine, rename that, just like so. B_spine2 there's no weights assigned with this vertex group, so we can just remove it with this minus icon here. This one would be for the hips bone. No weight. No weight. This is for the thigh bone. In this case, the thigh right. Assign it there. A tip here, if you don't want to navigate through the armature hierarchy to figure out what bone this could be assigned to, you can alt-click the nearest bone for this area to figure out the bone name, in this case upper arm right here, and then assign that the name. That's just if you want to get familiar with the bone hierarchy. Now just go through the list, renaming the vertex groups to the corresponding bone names, while being very careful not to accidentally delete vertex groups that have some weights assigned to them, as these are very annoying to fix later. Here for the B_head vertex group, you'll want to assign this to the head bone instead of the neck bone. Now let's combine these duplicate vertex groups together. The way to do that is go in the modifiers tab, add the vertex weight mix modifier a bunch of times. In the vertex group A slot, search for 001, choose the first option, copy the non-001 portion, in this case neck, delete the .001, leave just neck, and then paste neck. Now you'll see the options for neck, which are the duplicates. So we have 1 and 2. In this case, select 1. So we are combining the neck and neck 001 with the original one being the neck. Set the vertex set to all, mix mode to add. And repeat this for all of the duplicate vertex groups you have. In the case of this neck vertex group, we have 2 of them, so we still do neck as the original one, and neck 002 as the one we want to combine to the original one. Vertex set to all, mix mode to add. Once you've gone through all of them and you can't find any more unique vertex group names by typing 001, you can delete the excess vertex weight mix modifiers you made, and I suggest doing a save here, so a quick save with Ctrl S. At this point, apply all the vertex weight mix modifiers with Ctrl A while hovering over the modifier. Head over to the Data tab. Down here in the drop-down, sort by bone hierarchy. So at the very bottom, you'll see all the duplicate ones. Start from the one that doesn't have any numbers, and by using the arrow keys, go up the list of vertex groups while paying attention to the weight paint it's assigning to the mesh, and confirm that it looks correct. Once you've validated that the weight paints look correct, you can go down the list and remove all of the ones with .00 something appended. Now you'll want to do the same process for the 2 remaining meshes. So go into object mode, select the rig, hide the base mesh, unhide the attach mesh, and while holding shift, select the attach mesh, go to weight paint, here sort by name. Again, start from the bottom and start assigning these bone names to the vertex group names. Here in the attach mesh, you'll need to assign the names to these finger bones. Be very careful with these to assign them correctly, and don't accidentally delete them. Here with the pinky 0 bone, you'll want to assign this to the hand bone, because this is not a pinky finger. It takes more space in the hand bone itself. Assign the knee pads to the shin bone instead of the thigh bone. Now careful with these forearm helper vertex groups. They are assigned to the forearm, not the hand. including this one. And lastly, the helmet, which is quite simple. Select the rig, shift select the helmet, white paint, and it only usually has just one vertex group, so rename that to head, and we're done. Now with the weight paint assignments done, it's time to validate that the entire Spartan moves with the rig. Go to object mode, unhide all the meshes, select the rig, pose mode, select the hip bone, which is right here, and move the entire Spartan. If there are any floating parts of the Spartan, that means that those don't have weight paint, and those will need to be manually fixed. In our case, there was no issues, but there are bound to be some issues with the normal weight paints, so we will have to find those and then fix them manually. Common areas include the elbow coming out of the armor, annoying issues with the fingers when moving them to the extreme positions, such as moving the thumb here moves the armor plate. We'll need to fix that so the armor plate doesn't move with the thumb. Sometimes the knees come out when you move like here, such as a little bit here. The bottom of the foot, when moving the toe up, will disconnect. That will need to be fixed. When moving the hand bone upwards or downwards, it also moves the armor with it. That may want to be fixed. Or it deforms the top plate armor. And then a big issue here with the clavicles. If you move your arms up, VRChat locks the rotation of the shoulder bone about here, but when you move your arm up, your clavicle or your shoulder, one of your armpit, completely disconnects from the mesh. Same happens when you go downwards, disconnects from the top. Not so much when you move backwards or forwards, but it's still there. Also the head bone, when tilting the head upwards, there's an issue where it pulls apart of the neck. That will have to be fixed. After you've messed up your Spartan pose, you can select all the bones, go to pose, clear, transform all to reset the pose. Here, if you want to preview a somewhat realistic fist grasp, you can select the bones, the finger bones, except the thumb bone, all of them. Ensure that the pivot point is set to individual origins, and then rotate them like this. Also ensure transfer orientation is set to normal. This way you can rotate the finger bones naturally and see if there are any weight paint issues along with that, because these issues will be noticeable immediately when you grasp your hand in VRChat, but they may be difficult to find in Blender, so this is a good way to test that. To start fixing the weight paints, go to object mode, hide the meshes that the issue is not present in, select the rig, then the mesh, go to edit mode, go to the area where the issue is present in. So in this case, I'll be fixing the bottom of the foot. Press L in areas that you want to hide, and then press H to hide them. In this case, just here and here. Optionally, you can select the areas that you want to work on if you want to isolate them later. I'll preview it here. So selecting with L, then go to weight paint mode. Now since we have the bones and the mesh selected, I can use Alt click on the bones to, oops, wrong one, to select the weight paint associated with the bone. In this case, I'll want to null out the weight around this area, so when the toe is moved up, this part doesn't move. The red parts will move completely with the bone, and blue parts or black parts will not move at all, so we'll want to paint this black. In order to paint it like that, we do weight of 0 on the brush, and just paint it here, like this. If you want to mirror this at the same time to the other foot, we'll go up to here, press X here, and topology mirror here. Mirror vertex group set to on. Now when we paint something here, and take a look at the foot bone here, it has also been painted here. Keep in mind this is not always perfectly accurate. It is only accurate if the mesh is perfectly symmetrical. Well, most of the time it is. Let's see how that looks like. We can rotate the bone here in the same view. It looks like it's staying in place. Now there's another issue with the weight paints of the toe, where if you move the toe up, like you're tiptoeing, the bottom of the toe drags behind, and this will go into the ground in VRChat, so it doesn't look good. To fix it, we'll have to paint this part of the toe bone completely red, and then we'll also have to paint a part of the foot bone weight paint black here. So using my brush with a weight of 0 and the topology mirror on, just painting here. Okay, taking the toe bone, then with a weight of 1, painting this. There we go. And then the change is mirrored on the other side as well. Now when we rotate, the part of the toe doesn't drag behind anymore. Now I'll fix the elbows. Going back to edit mode. I'm going to hide parts around the elbows and just select the elbow. Go into weight paint, select the forearm bone, and in this case I'll want to use the paint mask. Now it only isolates this location of the mesh. I cannot adjust the weight paint of any other place than just this one with the paint mask on. I'll preview using the gradient, so I'll set the strength to 1 but weight to 0. So now when I paint, it is a gradient of 0 weight. Keep in mind, with the gradient tool, you cannot use the topology mirror at the same time. It doesn't work with the gradient tool. So I'll do a swipe like this to ensure that when the forearm bone is moved, this part doesn't move, so it doesn't go outside the armor. Now, since I used the paint mask, I'll have to do it on the other side as well. So going back to edit mode, selecting this, weight paint, and now I'll select the bone selection here so I can alt-click on these bones to get the selection. Back to paint mask, line myself up, get the gradient, and do that. Same thing in the shoulders. Hide these parts around here. And here I'll want to paint both the shoulder bone and the upper arm bone, since they both have weight around here, which contribute to the shoulder disconnecting from the chest. So I go up here, and I'll want to again do a blue/black paint around this area. Most easily shown here on the upper arm bone. So gradient, weight 0 with a strength of 1, and just painting across like this. Same for the shoulder. There we go. Now the blue/black parts won't move when you move the shoulder or the upper arm bone. In this case, the paint mask doesn't really matter. If we would be using a weight of 1 and then painting like this, you'll notice the gradient is much more noticeable, but since there's already a paint of 0 on the body elsewhere, we don't need to use the paint mask here. Then we have the neck. This one I'll want to just select the neck here, weight paint, and with the bone selection, select firstly the head bone. You'll see there's a weird splash of paint. I can easily get rid of that like here. And then select the neck bone, and we can use the sample weight to get a sample weight from here, from the green, and then just paint with that green around this area. There we go, that should fix the neck. Then there was some weirdness in the knees, so let's check those out. We'll just drag this to have more of the black or blue area. That should do it for the base mesh. Let's see how we've done. I'm gonna go to edit mode, press Alt H to unhide everything. Go to object mode, select the rig and then pose mode, and let's see. There we go, no big issues on the knees there. Toe doesn't extend out. Neck looks fine. Moving the clavicles or the shoulders doesn't disconnect it from the chest. This is a very important one. And then moving the forearm bone doesn't move the tech suit underneath from the armor. Then there was some issues with the hands. So I'll hide the base mesh, select the rig and then the attach mesh. In this case, the hand is already isolated, so we can just go straight to weight paint. And let's see here, when selecting the thumb bones, seems like thumb 1, you'll see it has paint on this top armor plate. We'll just want to get rid of that. So in this case, since I'm using the regular brush, I'll turn on the mirror vertex groups on the x-axis and topology mirror on. Then for this top armor plate on the hand, I don't want to move it at all when the hand moves up. In this case, if you look at the hand, it has a lot of the green paint instead of the whole plate being red. And I want the whole plate to be red. So first thing I'll try is go into edit mode and select just the plate. In this case, it seems to work just fine. Sometimes the plate is attached fully to the arm in the same group. This is present on the Mirage core, but here it seems to be separate, so we can just use L to select just the plate. When it looks like you have the full plate selected, go ahead and hide it and then fly inside it. You may find some like portions like this that you may have missed, so ensure you have all of those selected as well. Just unhide the selection there and then get this back. Selecting the hand bone, going here to paint mask, and now we're only adjusting the paint of this. So what we can do is straight up go into gradient, weight 1, and just make it straight up red. Now what we should also do is go into edit mode, hide the plate, go back to weight paint mode, and now with the hand selected, just go out of the paint mask. And now put some full paint around the very edges where this plate was. So these green parts won't move then as the hand moves as well. After making this rim of red weight paint, you also need to do the opposite on the forearm bone here. So selecting this and doing a rim of blue for here. Luckily, since we are using the brush and we have the topology mirror enabled, we should only need to do this for one hand because it mirrors it on the other hand as well. Annoyingly enough, this also has to be fixed on the thumb bone because it has some green here instead of blue. There we go. We can take a look at it on the other hand. Looks actually pretty good. And since we did the plate with the gradient, it didn't apply here. So let's fix that. Back to weight paint. Ensure the bone is selected. Go paint mask. And with the gradient, full weight of 1, paint that. Now we'll also have to remove any weight around this plate in the forearm bone. So if you select the forearm bone, you see there's some paint here. So select this again, go weight of 0 on the gradient and just paint over like that. We can now take a look at the hands in pose mode. So moving it up and down doesn't move the armor plate anymore. It intersects into the wrist, but I like it this way, where the armor plate doesn't move. If you make the fingers into a realistic fist here, and move the thumb, it also doesn't move the armor plates. Then after all the fixing, unhide your meshes, select the hip bones again, and rotate the entire body. Do some final checks to ensure that the weight panes look correct. In order for a Spartan to have accurate full body tracking in VRChat, we have to straighten out the legs, which currently hold an A pose. To get started, select all the bones, go to Pose, Clear Transform All, go to Transform Orientations, set it to Normal, pivot to Individual Origins, and select this, which is the X-axis mirror. Deselect the bones, select the left thigh, go to the rotation mode, and start dragging the blue axis. Type in -8.2, that'll straighten out the legs here. Go over to the left foot bone, move the green axis by 10, so type in 10. Move the red axis by 1.4. Change the transform orientations to global. And then move the blue by -7. You've now straightened out the legs. Now go to object mode. Select one of the meshes. Go to modifiers and apply the armature with Ctrl A. Repeat this for all the remaining meshes. Select the rig. Go to pose mode. Pose. Apply pose as rest pose. Go back to object mode. Select all the meshes. And while holding shift in the viewport, select the rig. Right click. Parent. Armature deform. Now you can select just the rig and go into pose mode and rotate the hip bone to ensure that the Spartan still rotates with the rig. Now since we straightened out the legs, the Spartan is actually slightly in the ground, so we'll have to lift up the Spartan to account for this. First ensure that your 3D cursor is set to 000. Go to object mode, select the rig, press G, Z, and type in 0.012. That will move the rig up just enough where it's at the correct height. Then select the rig and all the meshes. Go to Object, Set Origin, Origin to 3D Cursor. This moves the origin back to 000. And now we're done with the leg pose. Now all that's left to do is just one set of actions before we can export our Spartan. Go to File, Save As, and save a copy of this file called _bake. This will be a copy of the file with no destructive changes, since we will be doing those next. Now continuing from the regular non-copy version of the file, we will make some destructive changes. First of all, select the mesh, go to the Data tab, scroll down to UV maps, and delete both the UV0 and UV1 UV maps. Do this for all meshes, and you'll start to see that the textures start looking weird. Now go to the Materials tab, and remove all the materials on all the meshes. Next up, add one material per mesh that has the same name as the mesh itself. So copy the name, click New, set the material name as that, and do the same for the rest of the meshes. Then select all the meshes, and press Ctrl J to join them together. Rename the singular mesh to _PC, and now we're ready to export. Select the mesh and the rig, go over to File, Export, FBX, Click to include the selected objects only. Scroll down to Geometry, Vertex Colors to None. Click Open Armature, uncheck Add Leaf Bones, and uncheck Animation. Then export FBX. And that's it for the Blender side. Now let's move on to Unity. For the first time setup of Unity for VRChat, we'll need to install the VRChat Creator Companion. Watch this video to get started. And download the Rero standard shader. In the VRChat Creator Companion, go to the Projects tab on the left. Select Create New Project on the right. Select Unity 2022 Avatar Project. Give a project name and Create Project. If any updates to the VRChat Package Resolver tool, the SDK Base or SDK Avatars packages are present, apply them here. And open the project on the right. Once Unity has loaded up, drag the Rero standard shader from your PC to the Assets folder in the Unity project and press Import. Create a new folder called Avatar in the Assets folder and open it. Find the images of the baked textures we created and inspect the black emissive textures. If they're fully black with no emissive content, they can be deleted. Next, select the FBX and all the image files and drag them into the Avatar folder in Unity. To configure the Avatar rig, select the FBX of your Spartan and configure the rig as humanoid on the right here. Select Rig, Animation Type Humanoid, Apply, and Configure. Next up, fix any missing bone mappings. Common missing bones include the chest, shoulders, and spine. If any of these are missing in the mapping, drag the correct bones from the hierarchy to the inspector at the correct locations on the body. For VRChat use, we need to modify the height of the rig slightly to prevent an issue where the default VRChat pose is slightly in the ground. Select the hip bone, go down to Transform, the Z position, and type in plus 0.0001. Enter and click Apply. This raises the Spartan slightly above the ground in Unity, which fixes the issue in VRChat. At this point, you can go to the Muscles and Settings tab on the right and ensure moving the rig moves all the meshes correctly. Once you're done, you can press Done on the right. After configuring the rig, drag the FBX of the Spartan into the hierarchy on the left. On the right in the inspector, click Add Component, VRC Avatar Descriptor, and change the view position to be Y 2.06, Z 0.12. Next, let's set up the texture files. Select all the images. Set alpha source to none. Under the advanced drop-down, enable MIP streaming. Set MIPMAP filtering to Kaiser. Filter mode trilinear. Resize algorithm bilinear. Compression low quality. And enable use crunch compression. And press apply. Now select only the ORM textures. Disable sRGB color texture. And press apply. Select only the normal map textures. Set the texture type to normal map and press apply. Lastly, select only the base textures. Set the max size to 4096 and press apply. If you have any color textures that have transparent parts, select them. Set the alpha source to input texture alpha. Enable alpha is transparency and press apply. This will enable transparency in the texture. Next up, let's prepare the materials. Select the avatar in the Assets folder. On the top right, click Materials and Extract Materials. extract in the same folder. Select all of the extracted materials and set up the material properties. Set the shader to rerow, rerow standard metallic setup. Enable the custom rim. Set the albedo color to full white. Set the rim min-max all the way to the left. Enable advanced channel selection and enable GPU instancing. In the channel selection drop-downs, set metallic to B, roughness to G, and occlusion to R. Set the metallic scalar to 1 and the roughness scalar to 0.8. If you have textures with transparent parts, select the material where the textures will be applied to and set the rendering mode of the material to cutout. Now it's time to apply the textures to the materials. Select the material and drag the corresponding texture files for that material onto specific sections of the material properties. Color to albedo, ORM to metallic, ORM to roughness, normal to normal map, and ORM to occlusion. If you have an emissive texture, enable emission and drag the emissive texture to color. Set global illumination to none. And now just repeat this step for all the remaining materials. Now we're finally ready to upload the avatar to VRChat. Open the avatar build panel from VRChat SDK, show control panel. Log in with your VRChat account that you want to upload the avatar to. Note that your VRChat account has to have at least a new user trust rank to be able to upload the avatar to VRChat. In the avatar build panel, set the build type to build and publish your avatar online, and set the build platform to Windows. Press autofix on any alerts that give the option. Set at least the avatar name and an image. Optionally fill in more of the fields. When you're ready, press build and publish. At this point, you may be prompted to save the Unity scene, but it's not mandatory if you don't want to. Congratulations! Your avatar has now been uploaded to VRChat and can be found in the Avatars Uploaded tab. To get started with making a mobile or Quest-compatible variant of your Spartan, make a new folder in your project directory, copy the _bake file into there, and rename it _mobile. Then open that file. To make a mobile variant of our Spartan, we'll need to lower the fidelity of the model and then rebake the textures to work in a single material. First, we'll have to reduce the trees count of the model to be under 15,000 for a medium performance ranking or under 10,000 for a good ranking. To get started, let's first merge the nearby vertices of all meshes. Hide the rig, select all the meshes, go to edit mode, press Alt-H to reveal all sections of the mesh, A to select everything, M to merge, and select by distance. Down here on the left, ensure merge distance is set to 0.0001. Then go back to object mode. Now we will start reducing the fidelity of the model to go towards our target tree count. Select the mesh, go to the modifiers tab, and add the decimate modifier. Do this for all the meshes. Set the helmets ratio to 0.20, the base ratio to 0.18, and the attach ratio also to 0.18. Inspect the total tree count of the model and adjust the decimate ratio per mesh while still staying under your desired count and keeping the Spartan still looking decent. In my case, just setting the attach mesh ratio to 0.19 still stays under the 10,000 threshold I want to stay under, and the Spartan still looks fine. When you're happy with the result, apply all the decimate modifiers with Ctrl A. Now we can begin adjusting the textures. First, we'll adjust the UV atlas of all the meshes to fit in a single image. Go to the Data tab and ensure the Bake UV map is selected on all 3 meshes. Select the base mesh and go to the UV Editing tab. Select all faces of the base mesh by pressing A. Move your cursor to the left and press A again. Scale the space taken up by the UV atlas to be only 75% by typing in S, X, and then 0.75. Now go to Object Mode, select the helmet, Edit Mode, select all faces of the helmet with A, go over to the left, A again, and scale this part to take up only 12.5%. The way we will do that is by pressing S, X, 0.25, S, Y, 0.5. And now move this UV island by holding Ctrl into the top right here. Now do the same for the attach mesh. Go into Object Mode, select the attach mesh, Edit Mode, select all faces, press A here, SX 0.25, SY 0.5, and move it to the bottom right. Now if you look at the space taken up by all of our meshes, we can see they fill the square nicely, but everyone has their own allocated space. Lastly, combine all meshes into one by going to the Layout tab, selecting all 3 meshes, pressing Ctrl J. Ensure the selected UV map is set to Bake, and rename the mesh to _mobile. Now we can prepare the shaders for rebaking of the textures. Go to the Shading tab, select the Material tab, and delete the image texture for each material. Select the top material, create a new image texture, copy the name of your mesh, click New, set the name of the image texture to _mobile_, set the width and height to 2K, which is 2048, and uncheck alpha channel, because that's not supported in VRChat mobile. Then click New Image. Copy the image texture to every material in the mesh and ensure the image texture is the selected node in each material. At this point, bake all textures to this new 2K image texture. You can reference the PC texture baking process as it's the same. After you've done baking the textures, you should be left with just 3 to 4 image files. If that's true, you can go back to the Layout tab. At this point, save a copy of the file, File, Save Copy, and append _bake. This will again be a version of the model without any destructive changes. Now, remove the UV0 and UV1 UV maps, go to the Materials tab, delete all the materials, add a new material, and give it the name of your Spartan _mobile. Now we're ready to export the mobile variant of our Spartan. Select the mesh, unhide the rig and select that as well. Go to File, Export, FBX. Ensure selected objects is checked. Geometry, vertex colors none. Armature, uncheck add leaf bones and uncheck animation. Export. To begin setting up the mobile variant of your Spartan in Unity, continue from the existing Unity project for the PC Spartan you've already completed. Go to the avatar folder and create a new folder called Mobile. Then open it. Locate the folder on your PC where you saved all the assets from the Blender mobile process and import the files into Unity. Select the FBX file and all the image files and drag them into the mobile folder. Now configure the avatar rig and the VRC avatar descriptor for the mobile Spartan. You can reference the PC process for this as it's the same. After you're done, hide the PC avatar from the hierarchy. Next, optimize the textures just like in the PC process, but this time ignoring any transparency assignments and also making sure every texture has a max size of 2048, which is the default. Now we can set up the material for the mobile Spartan. Select the avatar, go to the top right, Materials, extract Materials, and extract it in the same folder. Select the extracted material and set up the material properties. Set the shader to VRChat, Mobile, Toon Standard. Set the main texture color to EC, which is a slightly darker white. Enable Use Normal Map. Set the shading to Realistic. Enable Occlusion. In Occlusion Map, set the color channel to red. Enable Specular. In Metallic Map, set the scalar to 1 and the color channel to blue. In Gloss Map, set the scalar to 0.65 and the color channel to red. Now apply the texture files to the material. Color to main texture. Normal map to normal map. Emission to emission map and set the color to full white. And ORM to occlusion map, metallic map, and gloss map. Now we'll need to connect the mobile variant of the avatar to the uploaded PC variant. Select the PC avatar from the hierarchy. In the VRC avatar descriptor on the bottom right, copy the blueprint ID, go to the mobile avatar, and in the same field, paste the blueprint ID and press Attach Optional. Now we're once again ready to upload the mobile variant of our Spartan to VRChat. This process is mostly the same as in the PC process with a couple differences. Open the avatar build panel from VRChat SDK, show control panel. You'll notice the build panel is for the already uploaded PC variant of the Spartan because we copied the same blueprint ID. Most of the fields in this build panel are already correct, but there's a couple options that we need to change. Ensure the selected avatar is set to the mobile variant, and the platform is set to Android and optionally iOS as well. It'll ask if you want to switch the build target, press confirm. After the platform switch has completed, press autofix on all the alerts that give the option to. Don't worry about the build download size too large for this platform alert, as it just hasn't updated to reflect the data from the mobile avatar variant. Ensure you have a name and image for the avatar, and then just press build and publish. If an error shows up when building the avatar, first try building it one more time, and if it happens again, then see what the error is about. Congratulations again! The mobile variant of your avatar is now uploaded to VRChat and will be seen by players using mobile clients like the MetaQuest 3 when you have your avatar equipped. To export your avatar as a Unity package, you'll first have to disconnect the blueprint ID. Select the avatar from the hierarchy, and on the bottom right, click Detach Optional on the blueprint ID. If you have a mobile variant of the avatar, do the same for that. Now head over to the Assets folder and drag your avatar from the hierarchy into the folder to make it into a prefab. If you have a mobile variant, drag that separately as well. Here you can optionally rename the prefabs if you want. Now to export the avatar, right-click the prefab, select Export Package, ensure Include Dependencies is checked, and press Export. Save it to a location, and you're done. To import an avatar package to VRChat, you'll first need to download the VRChat Creator Companion. Once you've got Unity installed through the app, head over to the Projects tab on the left, select Create New Project on the top right, select Unity 2022 Avatar Project, give the project a name, and select Create Project. If updates to the VRChat package resolver tool, SDK base, or SDK avatars are present, apply them. Then press Open Project on the top right. After the Unity project has opened, locate the avatar package you received and import it into Unity by dragging it into the Assets folder on the bottom. Press Import. If you have both a PC and mobile variant of your avatar, import and complete the uploading process for the PC avatar first, before doing so for the mobile variant. After the avatar package has been imported to Unity, select the prefab and drag it to the hierarchy on the top left. Now you're ready to upload the avatar to VRChat. Select VRChat SDK, show control panel, log into your VRChat account. Keep in mind that your trust rank in VRChat must be new user or hired to upload an avatar to VRChat. Once you've got the avatar build panel open, set the build type to build and publish your avatar online. Set the platform to Windows. Press autofix on any alerts if it gives you the option to. Set the avatar name and image. Optionally fill in more fields. Now just press build and publish. Unity will ask you to save the project, but it's not necessary if you don't want to. Your avatar is now uploaded to VRChat and can be found in the Avatars Uploaded tab. After a PC variant of your avatar has been uploaded to VRChat, locate the avatar package of the mobile variant and drag it into the Assets folder of the Unity project. Press Import. Drag the prefab of the mobile variant into the hierarchy on the top left. Optionally hide the PC variant in the hierarchy. Select the PC variant of the avatar and copy the blueprint ID from the bottom right. Select the mobile variant and paste the blueprint ID here. Then press Attach Optional. Unity will ask you to save the scene, but it's not necessary if you don't want to. Now we've connected the mobile variant of the avatar to the PC variant with the blueprint ID. After that, we are ready to upload the avatar variant to VRChat. Select VRChat SDK, show control panel, and you'll see the build panel is for the existing PC variant of the avatar. To upload the mobile variant of the avatar, set the selected avatar to the mobile variant, and change your platform to Android, or optionally iOS as well. Unity will ask you to switch the build target, press Confirm. You can now press Build and Publish to upload the mobile variant to VRChat. If you haven't saved the scene, you'll be prompted to save again, but it's not necessary to save. The mobile variant of your avatar has now been uploaded to VRChat and can be seen by players using mobile clients such as the MetaQuest 3 when you have your avatar equipped.
I did it!
Hey, Cobalt! Look at you, you finally got your suit!
Yeah, I didn't think it could be done, but here we are.
You've been MIA for days. What gives?
Well, you know I had no experience when going into it, but I decided to take on the challenge anyway.
And you did it. I'm so proud of you, Cobalt.
Thanks, Yellow.
So, what's next for you?
I think I'm gonna start a transport business.
Oh? What, like Cobalt cars?
Even better. Cobalt ships.
And how are you planning on doing that?
I don't know. I'll just fly by the seat of my pants.
I get it. It's like the show name.